So I hope you people can able to see my screen. I have already shared it, and if anybody could not able to see, please let me know. So today we are going to talk about the first topic as block space utilization parameters. Actually, these parameters we used to use in 8A version, but still we need to know them, what exactly they are, and what is the disadvantages of them and all. So that is why we are learning it here. So basically whatever the diagram you are seeing over there is a block, and every block will have a header portion. So that is where you can see the top portion as block header, and apart from that we have something called PCT free level, so which is representing at 20%, and then PCT user level which is showing at 40%. So we will see we will see all those parameters slowly. So there are totally 4 block space utilization parameters. First of all, what is mean by these parameters? As the name of the concept itself is explaining, you are going to efficiently use the space inside a block. So how we are going to do that? And it depends on these 4 parameters. So the first 2 parameters are init trans and max trans, as you can see in point A. So init trans is nothing but initial number of transactions, and the max trans is nothing but max number of transactions. So these 2 parameters are going to specify how many concurrent transactions or how many concurrent users can access a block in the database. And the default values will be, for the initial number of transactions, the default value is 1. That means minimum 1 user will be there to access the block, and the maximum the value will be 255. So 255 users can access a block at the same time, and that is what the max trans value defines. So these 2 parameter values, obviously in real time also we will not change them. Of course, when you go with 9i, 10g or 11g database, first of all we will not use these parameters. But still, if you are using these parameters in 8a version and all, generally or usually we will not change those values. So for init trans, the minimum or the value is 1, the default value is 1, and for max trans the default value is 255. So that is what about those two parameters. But well, before starting with the third one, that is mentioned in point B about PCT free, we need to know one important point, that whenever one user has been issued with an update statement, then that update statement actually may or may not increase the row size. So for suppose we are updating a value. So let me say I have written some statement like this. So I am showing 2 update statements over here. So we have 2 update statements, as you can see on the screen. Now in the first update statement, what I am doing is, for whatever the employee which is having the name as Kumar, so I am updating that name to Pawan. So in this statement, actually the row size will not increase. Why? Because Kumar is also 5 characters and it is going to occupy 20 bytes in the database, and Pawan is also of 5 characters. Again, this is also going to occupy 20 bytes in the database. But the difference comes in the second update statement. So when you issue the second update statement, actually the row size will increase. So what could be the reason? The reason is here you are updating the value from Kumar to something like Nagapavan. So in this case what happens is whatever the 5 characters that you are already having it, you are just replacing that with 10 characters here. So why I say 10 characters? Here you have a space. So in Oracle even space also will be considered as a character. So that's the reason this Kumar is being replaced with these 10 characters. So 10 into 4, each character is going to occupy 4 bytes. So 10 into 4 it is going to occupy 40 bytes. So that means sometimes your whatever the update statement that users are issuing may increase row size, and sometimes it may not increase the row size. But for example, if it is increasing the row size like what the example we have seen in the second update statement, in such case one row should get expanded means it need to have some free space in the block. So as we know already, block is nothing but the storage area where all the rows are going to reside. So if a row wants to increase or if a row wants to expand its size, then definitely it requires some space from the block, and that space it is going to take from a parameter called PCT free. So now you can read the description mentioned here. So it says PCT free is the reserved space that we have for future updates. So whenever any statement or any update statement basically wants to increase the row size because of some modification, then in such case it is going to take the space from the PCT3. So by default PCT3 will be declared as 20% size. That means if your block size is 8 KB, then it is going to occupy 20% of 8 KB. That means 1.6 KB. So basically in every block 1.6 KB will be reserved for future updates. And do remember PCT3 is only for updates, not for inserts or deletes. So this is about PCT free that we have. The next one we have is PCT used. So this one is a little bit different one. So PCT used is basically a level of or a level that you are going to represent inside a block, and the default level that will happen in the database is 40%. So what exactly is PCT used and how it is going to work? It is something like this. So let me take some example here so that you will understand it. So let's assume I have a block here, and I have a block header portion, then PCT free is also there, and the PCT used is defined at 40% level, let's say. So assume this is a fresh block. So I hope everybody can able to see what I am drawing. So is that visible to everyone? Okay, fine. So assuming this is an empty block or a new block, then let's say I started inserting some data. So let's say I started inserting some rows, and the row insertion was keep on going till this point. So till this level the insertion happened, and assume this level is at somewhere at 60%. So I mean from 0% to 60% I have inserted some data. Then after some months or after some weeks, what I have done is from the table I have deleted some rows. So this level, whatever the data level which is there at 60%, because now I deleted some data, automatically this level of data will also come down. So you can assume this level just like how the level will be represented in a test tube. So in a test tube, when you keep on pouring the solution, then the level will increase. It will show at 5 ml, 10 ml, something like that. And when you are taking out the solution, then the level will come down. So similar way, When I deleted some rows from the table, assume the level came down to 50%. So after deletion, the level came down to 50%. So in this kind of situation, so first what I have did, first I have inserted some data, the data level reached at 60%, then I deleted some data, then the level came down to 50%. Then once again after some days, I tried to insert the data, then Oracle will not allow me to insert above this 50%. So whatever the 50% level of data that we have, Oracle will not allow you to insert more than this 50%. That means whatever the gap you have between this 50% to 80%, because this 20 is for PCT free. So whatever the 50 to 80% you have, that means 30% of space is going to become waste for us. Now let me take another example. So I have another block. Similarly, I have a block header. Then PCT free is also there. Then PCT used is also defined at 40% level. So now into this block also I inserted some data. It reached 60%. Then I deleted some data. Then the level came down to. So I deleted so much of data. So the level came down to 35%. Let's say. So in this block what I have done is I have deleted so much of data. So that's the reason the level straight away fall from 60% to 35%. So after that level came down to 35%, let's say I started inserting the data once again, and in this case Oracle will allow me to insert the data. So in the first scenario, Oracle will not allow me to insert the data, but whereas in second scenario, it will allow me to insert the data. So what is the difference here? The difference lies in this PCT user level. So what happens in the first case is, in the first case, my PCT user level is defined at 40%, but when I removed some data, when I deleted some data, the data level didn't fall under this PCT free. So it came down to just 50%, which means it is above this 40%. So that's the reason Oracle will not allow you to do further more inserts. But when you come to the second example, here what happened is, when you deleted some data, the level of data came down to 35%, which is less than this 40%. And that is the reason Oracle allow you to insert the data once again. That means whenever you define your PCT used and you are doing some insertion and deletion, the data whatever you are going to delete, after that the level of the data should fall either equals to PCT used or less than PCT used. So then only Oracle will allow you again to reuse that particular block. So if after deletion the data level has not come down to PCT used or below that, then Oracle is not going to allow you to do furthermore insertions. And because of that, space wastage would be there. So this is what about PCT used means. So first of all, is this concept clear? Anybody is having any queries, please let me know. Yes, Sanjay, this is for table insertion only. So any more queries from anyone? Okay. Yes, I will come to that point, like when to go for PCT free and when to go for PCT use. So I hope the concept is clear first of all. So now, in which cases we need to go for PCT free? First, let's talk about PCT free. Now, the point which we already understood about PCT free is it is the reserved space for future updates and the default value is 20% of the block size. Now, for suppose if you know that in your database very frequently updates will happen, then in that case you need to have your PCT free level very high. That means if you know that in your database updates will happen very frequently or very rapidly, in such case PCT free instead of 20% you need to increase that to somewhere around 40% or 50%, or sometimes even it may go to 60 or 70%. Why? Because PCT free is the, whenever updates are being happen and if row size is getting incremented, then it would take space from the PCT free. Now, for example, in my database, the updates are happening very frequently, but I have not changed this PCT free level. I just gone with a default value of 20%. And let's assume when I'm doing this, my entire PCT free is already full. So assume a situation like that, and I have a row here which need to get expanded. So let's say this is a update statement happen on this row, and that the update statement try to increase the row size. So then what happens is, because already my PCT free is full, Oracle cannot increase the row size for this Oracle cannot increase the size of the row, and what Oracle will do is it will remove this row from this block and it will transfer this to some other block. Means the entire row will be moved from one block to another block. So wherever PCT free is available, Oracle is going to move this particular row to that particular block, and this we call it as row migration. So the concept name we call it as row migration. And what would be the solution? The solution is to increase the PCT free level. So instead of going with the default value of 20%, you need to go and increase to a higher value. Then this row migration will not take place. Now, what happens if a row migration takes place? Row migration will lead to database performance degradation. The reason is, when you do a select on this particular table, then Oracle need to read all the rows from this particular block, but only for one row it need to access this block. That means this is a IO and this is also a IO. That means for one table data you are performing two IOs, and too much IOs are going to degrade the performance of database. So that is the reason maximum we need to make sure that the data of a table, or if possible, should be there inside one particular block, or maximum you need to try to reduce as many IOs as possible. So if you want to make sure about that, then you need to have the right size for the PCT free. So is this point clear? So this applies only for the databases which are having very frequent updates happening. For example, you can take any banking database. Suppose when you are depositing some money, then it will be an update statement. You are updating your account balance from X amount to Y amount. That is nothing but depositing the money. When you are withdrawing the money, then also it is updating from a higher value to a lower value. So like this, in banking sector, mostly you will be observing frequent updates will be happening out. So in those kind of databases, instead of having 20% as the PCT free, you need to have somewhat a bit more size. Then the performance issues will be resolved. So is this clear? If you have any questions, just let me know. Okay. Now let us talk about PCT used. So what about this level? So as we saw PCT user level, majorly the PCT user level is creating an impact when the delete and insertions are happening. So if you know that delete and inserts are being happened in your database very frequently, in such case you need to keep you need to keep this PCT user level as low as possible, because if after deletion, if your data level doesn't come down below 40%, that is what we saw in the first example, Oracle will not allow you to use that space. So that is the reason it is, if you know that deletes will happen in my database, but not major deletes, but some 3 rows deleted, or some deletes will happen in my database, but very less deletes will happen, or very less number of rows will be deleted. In such case, you need to have this PCT user level also very high. So instead of 40%, you need to declare it as somewhere around 60% also. Suppose you know that in your database deletes will happen, and at the same time that too this delete will be deleting huge number of rows. So there are 2 points here: delete occurring in a database, but deleting some set of rows, small number of rows, and deleting major number of rows. So when you are deleting small set of rows, then you need to have this PCT user level as high as possible. When you are deleting huge number of rows, then you need to have this PCT user level as low as possible. So then efficiently you can make use of the block space. So is this point also clear for everyone? So even in this example, what I am talking about, delete and insert statements should be more. So this applies once again. The example will be from banking sector only, because whenever uh, you do a monthly transaction, then in that particular month that will be an insert statement, or whenever you do some loan repayment. So it's something like in one table you are going to delete the values, and in another table you are going to insert and then update. So for one transaction there could be multiple things that are involved. So basically this PCT free and PCT used will have more impact on a OLTP environment. So we call it as online transaction processing, which is nothing but where DML and DDL statements will have more impact. And suppose you have a data warehouse environment, or any other database which is a combination of both OLTP and data warehouse. In those situations, you may not go and use this block space utilization parameters, or you may not go and increase these PCT free values and PCT used values. So depends on the database, you are going to react accordingly. So that is what we have the things about PCT free and PCT used. So the advantage that we have is from 9A onwards, this we don't require to use these PCT free and PCT used values. I mean, we don't require to take care of either increasing or decreasing the things. The reason is Oracle has automated these tasks. So it can decide what value of PCT free should be there and what value of PCT used should be there, and it can adjust these values automatically from 9A onwards, and that too in a special type of table space, and we call it as locally managed table space. And that is why you can see a note here, which space block space utilization parameters are deprecated from locally managed table spaces. So any queries before we move to the next concept? Okay, so let us go to the next concept, that is local versus dictionary managed table space. So basically table spaces are divided into two categories. One we call it as locally managed table space, and the second one we call it as dictionary managed table space. So we will be getting a question usually in interviews, what is the difference between them. So with this concept we are going to understand, or we are trying to understand about that. So first we will see what is dictionary managed table space and what are its disadvantages and all. Then we will go back to the locally managed table space. So now here, so the diagram which currently on the screen is dictionary managed table space. So dictionary managed table space is also shortly called as DMT. So what happens in dictionary managed table space is, we know very well that DB writer is going to write the data, or DB writer is going to write the dirty blocks into the data files. So whenever DB writer wants to write in those dirty blocks into the data files, then it need to know which block is free and which block is used. Because already if a block is used, then DB writer cannot go and write the data into it. So it need to skip that one, and it need to write only into free blocks. So when DB writer is supposed to write into the data files in dictionary managed table space, what happens is it couldn't able to get the information like which block is free and which block is used. So DB writer is going to take the help of server process. So it will go and ask server process, boss, please do provide me the list of free blocks so that I can go and write into them. Then what server process will do is, server process will go to data dictionary cache. Here you can see that. So shortly we call it as DDC. So it will go to data dictionary cache, and inside data dictionary cache there will be a table what you are seeing on the right hand side. So this table we usually call it as free list. So the name of this table is called as free list. So under this table, there will be block information residing. For example, like what you can see on the screen, 121 is used, and 122 is free, and 123 is again used. So what server process will do is, it will go to this data dictionary cache, and it will read or scan that particular free list table, and because already 121 and 123 are used, I cannot give that information to DB writer. So server process will take the information about 122, the block ID 122, which is free, and then it is going to update DB writer, or it is going to inform DB writer that yes, you can go and write into block number 122. So then DB writer will come to data files and it will write into 122. Now after writing down into 122, if DB writer still requires some other blocks to be written, again it will contact server process, again server process will go to data dictionary, again it will read this block information, etc. So that means for every free block this exercise should be done. DB writer contacting server process contacting data dictionary cache, then reading out the table, then again informing DB writer. So all these actions should be taken place for each and every free block. Now the problem here is the data files will be residing on disk, and the data dictionary cache is a memory area. So this is a memory area and this is a disk, and we already know memory to disk is always an IO. So that is the reason when DB writer wants to write into more and more blocks, then you would be observing some performance degradation, because every time server process need to contact data dictionary cache, and there is a IO involved. So that is the reason this dictionary managed table space will have some performance issues. So similarly, when we come to locally managed table space, the advantage that Oracle has given us. So as you can see in the screen, from locally managed table space onwards, the free block information is used to be maintained in the data file header itself. So if you assume this entire thing as a data file, this particular table what you are seeing is residing in data file header. So the block ID and as well as the status of the block, whether the block is occupied or whether the block is free. So it is represented with the help of zeros and ones in the data file header itself. And because you are storing this information in the header itself, you don't require to travel to data dictionary cache, and thereby IO is avoided. And the moment IO is avoided, you can see the performance gain will be there. So this is the difference between dictionary managed table space and locally managed table space. In dictionary managed table space, the free block information is maintained in data dictionary cache in the form of a table and we call the table as free list. Similar to that, in locally managed table space, the free block information is maintained in the data file header itself, and this table we are going to call it as bitmap block. Sorry. So this table we are going to call it as bitmap block. So from where it is going to pick up the free block information. So 1 means occupied, 0 means free. So is this clear or any questions? Okay. Now there is a note here at the end. So you can see that in any version we can create dictionary managed table space only if the system table space is dictionary. So for example, in 9i, 10g or 11g versions or in 8i, any version, if you want to create a dictionary managed table space, then first of all your system table space should be dictionary table space, or your system table space first of all should be of dictionary type. Suppose if your system table space is local, then you cannot create a dictionary managed table space in your database. So we will be seeing that anyways. So let us go for the next thing. So whatever on the screen you are seeing is a table space creation syntax. So there are the feature and the options, different phrases that we have in the syntax. So let us go through this to understand what exactly it is. So we have the first line as create table space name. Then we know that every table space is residing, or every table is integrated with a data file. So that's the reason we are going to use the second line, data file and its path and file name, then the size of the data file. So this is what we are going to specify in first two lines. So first one is create table space name, then data file name, and then the size. Then we have an option called auto extend on. So this is one of the good options that we have from 8i onwards. So when you make this auto extend on, then what happens? As you can see the word auto extend, that means you are going to tell to Oracle that you want to let Oracle take care of some extension. Automatically it should get extended. Now what should get extended? So it is the data file which you want to get extended. So data file, initially you declared it as 50 MB, but you can keep that in auto extend on mode. so that this 50 MB, once it is full, it can start increasing on its own. And once this 50 MB is full and data file starts increasing on its own, then you can define some max size to it. Means this auto extend on should be done only to this maximum size. For example, you can see on the screen we have defined max size of 200 MB. That means your data file initial size is 50 MB, but once this 50 MB is full, it can start increasing to 75 MB, 100 MB, then etc. etc. So till it can go till 200 MB. Now even after 200 MB, if data file is trying to increase, then Oracle will throw an error. Why? Because we already specified the max size to be 200 MB, so Oracle cannot increase more than that. So this is the purpose of auto extend on. So especially it is going to help you in scenarios where you cannot decide how much could be the data file size. For example, your application team said we are going to load some data in the table, but they are not sure how much data load is going to happen. So it could be 1 GB of data load or 2 GB of data load, or they are also not sure. In that case, what we can do is we can just make this auto extend on and we can define some max size. Now if you don't define some max size, then Oracle will by default take unlimited value. That means if your hard disk size is 70 GB, then Oracle will grow this data file till that 70 GB. That means it will take the maximum value or unlimited value. So that is where if some people or application team is doing the data loading, but they are not sure about how much data load is going to happen, in such scenarios you can make use of this particular parameter, auto extend on and max size. Then the fourth line, extend management local or dictionary, whether it is a locally managed device or dictionary managed device. So by default, local. So that is the reason you can see local was made in bold. Raghu, can you please turn off your speakers, please, or place it in mute. Thank you. So yeah, so we were talking about extend management, and as I said, local is the default one from 9A onwards. So that is the reason you can see that in bold. And if you want, you can also create a dictionary managed namespace. And the next one we have is segment space management, auto or manual. So what is mean by segment space management? So when you have some insertions and deletions happening inside a table, then usually the tables will get fragmented, and more than a table level, the underlying blocks will get fragmented. So to avoid this kind of fragmentation at block level, we have a concept called coalescing. So the concept of coalescing is nothing but adjusting the data wherever it is possible. So let me show you how it is going to happen. So let's say I have 3 blocks like this. And these blocks, assume the data are like this. So let's say you have 3 blocks like this. The first block is almost 75% full, and the second one is 25% full, and third one is a free block. So why this kind of situation occurred? Because you deleted some rows from this block and from the second block also, then this kind of situation may occur. Now in these kind of situations, what Oracle will do is it will do something called coalescing. So how that coalescing will be done, or what is meant by coalescing, you will understand it now. So that the above diagram is before coalescing and the below diagram is after coalescing. So this is what will happen after coalescing. That means whatever the data you have in the second block, this 25% of data is being copied into this block, then automatically second block will become a free block. So basically you are adjusting the data from one block to another block, and this we call it as coalescing. And this coalescing is going to take place automatically by SMON. I mean, SMON usually do this task, and with the help of the concept segment space management auto. That means if you have automatic segment space management enabled, then only SMON will do this task. Suppose if you declare segment space management as manual, then SMON will not do this task on its own. As a DBA, we need to run some commands and we need to do the coalescing manually. But from 10G onwards, this is automatic segment space management by default. In 9i, it is manual segment space management. So in 9i, segment space management is there, but by default it is manual. But when it comes to 10G, it was made as automated. So that's the basic purpose of segment space management. The init trans, max trans, PCT3 and PCTUs, just now we discussed that, and we already understood that it is only for dictionary managed table space. And then we have initial 1M and next 5M. So what is mean by this initial 1M and next 5M is, so when we declare this 50 MB as my data file size, then what Oracle will do is, it will not give entire 50 MB at the same time. Rather, out of 50 MB, it will give only 1 MB for you, because here you declared initially as 1 MB. Now let's say when you occupy this entire 1 MB, then Oracle is going to give you 5 MB, because we declare next as 5 MB. And it is not mandatory that you should declare 1 MB and 5 MB. You can take any values. Initial also I can take 5 MB, next also I can take 5 MB, or initially if I take 1 MB, next also I can take 1 MB. So it depends on. So when we have this, so initial it is 1 MB, the next one is 5 MB. So Oracle is going to allocate you 5 MB of extent. And coming to the third one, so first extent will be 1 MB, second extent will be 5 MB, then what about third extent? Third extent value is dependent on the next line. So if you say uniform, the third extent, if you say uniform, the third extent size also will be of 5 MB, because it is going to maintain the same order. So even the fourth extent size will be 5 MB, fifth extent size will be 5 MB. So all this will be 5 MB by default when you say uniform. But when you say PCT increase, that is nothing but percentage increase. That means to previous extent, the current extent or the new extent should get more size. And by default, the PCT increase value is 50%. That means if my second block or second extent size is 5 MB, for example, then the third extent size would be 50% of 5 MB. That means it is 7.5 MB. I mean 5 MB plus 50% of 5 MB. If we calculate that, it will be 7.5 MB. Then the fourth extent size will be 7.5 plus 50% of 7.5. So it will come nearly to 12 point something. So then fifth extent will be 12 point whatever the value you have into 50% of, sorry, plus 50% of that 12 point something. That means your fourth extent or fifth extent will have more size, then sixth will have much more size. So your extent size will keep on growing. So when you have a concept like this, when extent size are growing irregularly, then at one moment, one extent size itself you can fill into GBs. So because it is growing by 50%, one extent size itself can grow into GB size. So which is usually not a good idea to work on. So that's the reason always uniform is a better option. But avoiding uniform, Oracle 10G introduced a new concept called auto allocate. So what is the advantage with auto allocate is, if you want 2 MB, then Oracle is going to allocate only 2 MB for you. If you want 5 MB, then Oracle is going to allocate 5 MB for you. So whatever the values that you want, it is going to allocate on its own, and we call that as auto allocate feature. So this concept is new from 10G onwards. In 9i we don't have auto allocate option. And then we have logging and no logging. So logging means any DML or DDL operation should generate redo entries, and the no logging means any DML or DDL operation should not generate redo entries. So that means when you specify a table space as no logging, and if you perform some DML transaction, then usually redo entries will not be generated. And the last one we have is block size, but that is usually an optional one. So this is basically the table space creation syntax. So anybody is having any queries here? So coming to your question, Raghu, yes, after the introduction of locally managed table space, we are not using dictionary managed table space because it is of no use now. So anyone is having any queries in these parameters? Okay. So just now we discussed the point about logging and no logging, and as I said, logging means redo entries will be generated, and no logging means redo entries will not be generated. But every time we cannot use no logging. No logging is applicable only in certain situations. So in below note you have those situations mentioned. So it says, even though we specify a table space as no logging, still all the DML transactions will generate redo entries, and why we require that is to do instance recovery. And no logging is applicable only for the below situations. So the situations are whenever you are creating table B from A, so that means you are duplicating a table. In such case you can use no logging. And whenever you are inserting some data into a second table from first table, then also you can use no logging. And whenever you are rebuilding your index, then also you can use no logging. So what exactly mean by rebuilding the index? It's nothing but dropping and recreating the index. And next, whenever you are creating an index also you can use no logging. And fifth one, any DML operations that you perform on LOB segments. So even in that situation, no logging is going to work, except these 5 situations. In any other case, even though you specify no logging, still Oracle will log the data. So that is what one of the important points that we need to remember. Yeah, answering to what Funny asked, we have a view Funny, a view called db underscore table spaces. So that view will actually tell you whether your table space is dictionary managed or a locally managed table space. So we will see that in practical. So let us move to the command section, and we will see what are the commands to create the table space and etc. So if you look at the commands here, the first one is creating the table space. One line we are going to mention, and second line we are going to write down the data file, its location and the size. So apart from this, we have not even specified any of other parameters, like we have not specified auto extend on, then extend management, etc. etc. So the reason is, by default there are some values like extend management is local by default, segment space management is auto by default, and because from 9A onwards it is locally managed table space, we are not using these 4 parameters. And even if it is a uh, local managed table space, we don't require initial and next, because everything will be managed with auto allocate, and even logging is also default. So that's the reason in the command, while creating the table space, we have not specified any other parameters, only the first 2 lines. But when you create the same table space in 9i, you require the third line. Why? Because as I already told you, segment space management is manual by default in 9i. So you need to exclusively mention the third line. But whereas in 10G it is automated. So that's the reason we even don't require that particular line. So let us go and look into the things. So if you want to know about already existing table spaces, because whenever you create tables database, 4 table spaces will be created by default: system, sysops, temp and undo. So if you want to know about those table spaces information, then you can query this particular view. So there is a view called db underscore table spaces, which is going to provide you information about the existing table spaces and their nature, means whether they are locally managed or not, etc. So there are certain columns here. Let me show you something like table space name, then contents, extend management, allocation type and segment space management. So you can see over here, for each and every table space it is going to list down what is the content and which type of table space it is, and allocation type, it is nothing, system means auto allocate. So in theory we may read it as auto allocate here, but coming to the value that is going to be stored, it will store as system. Then what is your segment space management is? So it is going to list down all this information for existing table spaces. So if your content of a table space is temporary, then it is a temp table space, and if your content is undo, then it will be an undo table space. So, and now you can see this particular view db underscore table spaces will talk about only the table space information, but not the data files information. So if you want to know about data files information, then you need to make use of this particular view db underscore data underscore files. So this view will give you information about the data files of those table spaces. For example, you can say table space name, comma, file name from db underscore data underscore files. So it is going to list you what is the table space name and what is the corresponding data file. Undo table space, its corresponding data file, sysops and its corresponding data file, all those things. So basically these two are the views that we are going to use. So let us go and create one table space. So I'm using the command create table space my TBS, and data file I'm giving the similar location. And when you are creating the table space, we need to specify the name. Sorry, give me a moment. Yeah. So when we are creating the table space, we need to specify the name and the size. And the naming convention is one thing that we follow very standard one. So the standard one that we follow is, whenever you want to specify the name for the data file, we will first take the table space name, and then we will start with a count of 1, then 2, 3, something like that. So if this data file is the first data file of this table space, then we call it as something like what I have written there, by tbs01.dbf. So if you are going to add one more data file to this table space, then the name will be mytbs02.dbf. So it happens like that, and then we need to specify the size. So for example, size of 50 MB. So as I said, from 10G onwards, you just require these two lines so that the table space will be created. And now if you run the same select statement, you can see your new table space name is also, that is my TBS. So this is how we are going to create a table space. Then we can create a dictionary managed table space with these commands. So let us try to create it. And already we have seen one point, one note stating that you can create dictionary managed table space only if your system table space is dictionary. But in our case, system table space is local, so that is the reason you cannot create a dictionary managed table space. So I am taking an example to show how it will fail, and I am taking the name as DicTBS, and giving the location like this, DicTBS01.dbf, and you can see it says invalid create command. Sorry, the command I have given is wrong, it's not correct. Oops. So this is the command to drop a table space. We will see that anyway. So then we say extent management dictionary. So now you can see it is clearly stating you cannot create a dictionary managed table space because your system is local. If your system table space is dictionary managed table space, then only you can even create a normal table space as dictionary managed table space. And then you have commands on how to enable auto extend on, how to disable auto extend on, and all. So let's go and see them. And auto extend on, you can place it only at data files level, not at table space level. Means you cannot say one table space should be there in auto extend on. Rather than saying that, you can say under this table space I have this data file, and that data file I want to keep it in auto extend on mode. So you can say something like that. So for example, I want one data file to be auto extend on. Let's say I want this particular data file to be auto extend on, then I need to write down my command like this. So we need to say alter database data file, then its location and the file name, and we say auto extend on, and the max size is 75 MB. So initially I created with 50 MB and I have given max size of 75 MB, so it can grow only till this particular level. And if you want to turn off auto extend on, you can also do that to or with the similar command by saying auto extend off. So these two are the commands in order to turn auto extend on or off. So apart from this auto extend on, you have also another chance to resize the data file. So let us go and see those commands. So the first command I am going to show is how to resize your data file. So the command would be pretty simple. So this is how you are going to resize the file. So for example, if your existing data file has reached that 50 MB whatever I have given, you can resize that to 80 MB. I mean any value. So apart from resizing, you have another option also, that you can go and add the data file. So for that you are going to use the command like this. So when you are adding a data file to the existing table space, usually again here it is recommended to follow OFA. That means if you have one data file already in U01 location, it is to better add the second data file in another location. So this is to follow OFA, so that the two different data files will be there in two different hard drives, and that IO header is going to do the one parallel. So now you can see the file got added here, and if you look at so you can see both the files are there, but one file is there in U01 location and the second file is there in U02 location. So usually when your table space is reaching the maximum or threshold value, you will be having this option either to resize a data file or to add a data file. Now every time there will be an argument stating which one is better, whether to add a data file is better or whether you resize a data file is better. So the answer for this is this particular note. So you can read the note which says adding the data file for the table space size increment is the best option, but only if you have multiple hard disks, because we need to follow OFA. Suppose you have only one hard disk, then either you resize it or you add it, it's not going to show much impact. So that is one important point we need to remember. And the second important point is the note which is there above, which says if you have multiple data files, then extents will be allocated in a round robin fashion from these data files. That means here I have two data files. The first file is of 50 MB and second file is also of 50 MB. Now whenever you create one table and you start inserting the data, then how Oracle will fill up the space? Usually what we assume is Oracle will start filling up the first file, then once first file is full, then it will come to second file. This is what usually our interpretation would be. But frankly, Oracle is not going to handle in that way. It is going to use both the data files at the same time. So that means if it allocates the first extent from the first data file, it will allocate the second extent from second data file. then third extend from first data file, and fourth extend from second data file. So like this, it is going to distribute the data across multiple data files in a round robin fashion. So that is what this particular note is going to talk about. And before we go for renaming the table space, now if at all you have created one dictionary managed table space and you want to convert that dictionary managed table space to local, or suppose you have locally managed table space but you want to convert that to dictionary managed table space because of a reason. So in both the situations, it is possible with the help of the commands you are seeing on the screen. So the first command is going to allow a particular table space to be converted from dictionary to local, and the second command is going to do the reverse, that is, it is going to convert from local to dictionary. So and also there is a note which says local to dictionary conversion is possible only if the system table space is not local or system table space is dictionary. So this is how we have the commands in place. Any queries over here till now, whatever on the commands that we saw? Okay, fine. So that is all we have for today's class. So the rest of the commands and other topics we will be looking in the next class. Now let us decide whether we want class tomorrow or not.